Welcome to another video on digital electronics. In this video, we'll be solving a numerical which is given to you. Realize the logic function of the truth table using a 8:1 marks. If you look at the truth table, you can see 4 variables. If you have 4 variables available to you, which means 2 raised to 4 will have 16 combinations. Right? So all the 16 combinations are listed down and you have the output recorded for all those combinations. But you have been asked to implement this using a 8:1 marks. So had you been given a 16:1 marks, it is easy. You simply connect 1 to whichever minterm is available and 0 to wherever the output is 0. It is simple. But given the fact that you have constraint on the availability of the multiplexer, which is 8:1, you have now to reduce this truth table and implement using a 8:1 marks. So the simplest method of doing this is to create a bifurcation considering one variable, which is d. So there are other methods also to solve this using a box method, which many students prefer to do, but this is the one of the simplest methods, so you can follow this. So now I will write my new output y with respect to this variable d. So now my input to the multiplexer select lines will have only 3 variables a, b and c. So 2 raised to 3 is nothing but 8. So using 8:1 marks, now I can very easily implement this. You now have to bifurcate in rows also, which means wherever a, b and c are same, I will create a bifurcation here. So a is 0, b is 0, c is 0. Similarly, it is 0, 0 and 0 here also. So I will now write my new output with respect to d. So when d is 0 here and d is 1 here, when both inputs are 0, 0, 0, my output is 0. So irrespective of value of d being 0 or 1, my output is 0. So I will consider my output to be 0 for both these cases. Right? Similarly, now I will consider the second case where a, b, c is 0, 0 and 1, 0, 0 and 1. I will create a new line here. And now I will write my output with respect to d. So when d is 0, my y is 1. When my d is 1, my y is 0. Which means given any condition, the output is the complement of d. So this will be d bar. Similarly, for the second case, keep creating bifurcations of 2 lines and create your new output here. So for the second case, when your d is 0, your y is 1. When d is 1, y is 0, which means it is complementing in both the cases. So output is d bar. For the next case, your d is 0 or 1, your output remains 1. So when it is strictly 1, irrespective of the input, my output is 1. For the next case, d is 0, y is 0, d is 1, y is 1, which means it is exactly same as d. So I'll write d here. The next case 0, 1, the output is 1 for both the cases, so it is 1. For next case 0, output has 1, 1, output is 0. So the output here is d bar again. And for the last case, for 0 I have output 0, for 1 I have output 1, which means it is same as d. So this is my new reduced state of the output, in which now how many outputs do we have? 8. 1, 2, 3, 4, 5, 6, 7 and 8. So I have 8 outputs which I can now implement using a 8:1 marks. So how do we do that? It is simple. You take a 8:1 marks. I will do it here so that it is feasible to check the outputs and implement. This is why I have 3 inputs a, b and c. These are my select lines. I have 8 combinations of them. 0, 1, 2, 3, 4, 5, 6, 7 and 8. So 0 to 7, 8 is not required. Sorry. Okay, so 8 is not required, 0 to 7 is fine. I'll connect 0 to logic 0. So now how many types of output you will have? Either the output will be 0 or it will be 1 or it will be d or d bar. So these 4 inputs I have to make available. So let's make logic 0 line here. This is logic 1 line. Wherever 1 will come, we'll connect it to this line. Then we'll make one line for D and a NOT gate, and the other one for D bar. So this is D and this is D bar. So 4 lines I have made. Just keep connecting to what comes first. So 0 is connected to logic 0. So here goes logic 0. And we do not have any other logic 0. So our work is done. For 1 and 2, the output is connected to D bar. So for 1 and 2, it is connected to D bar. Then we have 3 logic 1. So 3 goes to logic 1. 4 goes to D. 5 goes to 1. 6 goes to D bar. And 7 goes to D. Right? So this is how we implement 8:1 mux. So we have implemented 16 combinations, 4 variables using only 8:1. Right? So if I want to say check that whether my implementation is correct or not, how do we do that? Simple. Let's do for different combinations to see whether we get the required output or not. So let's take a combination, say this. I will check for this combination. Right? So what is my ABC? My ABC is 0, 0, 1. When my ABC is 0, 0, 1, I am connected to the first state. I am connected to the first state. This is what I am connected to. Now it depends on D, right? Because 1 is connected to D bar. So since 1 is connected to D bar, now it depends on D, what the value of D is. D bar will be complement of it. So I should get both these combinations. So let's see if we get that. When we have 0, 0, 1 and my D is equal to 1, which is the second case. If you can see here, D is equal to 1 and 0, 0, 1. So when it is 0, 0, 1 at the select line, 1 gets selected. D का वैल्यू अगर 1 है तो D bar will automatically, because 1 is connected to D bar, right? So my D bar will automatically be equal to 0. And see, my output is 0 here. So I am getting what my output should be. Let's check the condition which is above this, when D is equal to 0. So when D is equal to 0, your D bar will be 1, right? So for 0, 0, 0 at the select lines, I will again come to 1. 1 is connected to D bar. If my D is 0 in this case, my D bar is 1. So since 1 is connected to D bar, my output is 1. And which is the case here. So if D is 0, my output is 1. So both these conditions are satisfied, or I am getting the output for both of these conditions depending on the value of D, and hence you have a variable D at the input. So in this way, all the 16 combinations you can check using 8:1 mux. At one pin you will get 2 outputs, that is for sure. So this is how we implement 16:1 variable kind of a question using a smaller 8:1 mux. So you can still further reduce this if you want to implement using a 4:1, that is also possible. It will complicate your circuit design a bit. Now you will have to check for 2 variable combinations and so on. So this is it for now. Thank you for watching.